Hello, this is Ujjwal Gandhi from Spatial Thoughts. Welcome to our series on learning how to do geospatial data processing with XArray. Today in this tutorial, you're going to learn how to take a bunch of raster tiles, mosaic them, and then clip them using vector dataset. Let's open the linked Colab notebook and we're going to go through the tutorial step by step. We will work with SRTM data. This is an elevation dataset. When you download it, it comes in form of tiles, and a single tile may not cover your region of interest, so you may have to download multiple tiles and then you have to mosaic them together and then clip out the pixels that you don't need. We'll start by downloading the data. In this tutorial, we've already downloaded the data for Sri Lanka and it's provided with a tutorial. If you want to download data for your own region, this is a really handy utility. I use this a lot. You can just go to your region of interest, find the tile that you need for SRTM, and then just click to download it. You'll need an USGS account to download the data. If you don't have one, create a free account and then you'll be able to download this data. Start by installing the required libraries. We're going to use rioxarray. This is a library that adds the support for reading, writing raster data and a bunch of raster operations to XArray. This is based on the popular rasterio library, but this is an extension for XArray. Whenever you're using rioxarray, the way it works is even if you don't use any functions from rioxarray, but you want to have your datasets be understood by XArray as raster datasets, you always need to import it. So just make sure you always import the library which enables this extension for XArray. So here we import the extension to enable it. We're going to use one function from rioxarray which is for merging different data arrays. So we need individual tiles as arrays and then we will merge them. We're going to download some data. So here this is a helper function. We already have this data sets that we've downloaded and put it on GitHub. This is going to go and download this data. So if you see the files here, the data folder should already have the SRTM tiles. This dataset comes in as zipped files. Inside the zip file, there'll be an HGT file, which is the raster format that SRTM uses. rioxarray uses GDAL to read and write raster data, and it understands how to read this data. It also understands how to read the data from the zip file directly, so we don't even need to unzip it. First, let's get to the dataset that we need for admin boundaries. Here, we have provided one shapefile from Natural Earth data. This is just a countries file. If I just look at the geodata frame that we have, it has got the admin tree codes and names for each country. So if you want the boundary for a country, we just want to filter it by either the name of the country or the admin code for that particular country. We want to extract the boundary for Sri Lanka. So we'll filter this geodata frame saying wherever the admin A3 code is LKA, which is the code for Sri Lanka. And when we extract the geometry, we'll just get the polygon for Sri Lanka. And we'll use this to clip the final mosaic raster to the boundary of Sri Lanka. So next we want to read all the tiles using rioxarray. We want to write a for loop. We have a bunch of tiles in this list. So we iterate through it using a for loop. And once we construct the path to the zip file, we can just use the rioxarray's open rasterio function. And we say, just open the zip file and create a rasterio data array. And since we want to merge them, we just append this to a list. So when we run the code, we'll have a list of data arrays. We can also see this if I just say datasets of 0, this will show me the first dataset. So this is one raster tile that we have read from the zip file. And you can see this one has 3,600 rows and columns and just one band. And again, if you just go through the list, there'll be a bunch of these different tiles. So now we have all of them in a list and we can then merge them. It'll be nice to just get a sense whether all the tiles that we have cover the required region of interest or not. So we can extract the bounding box. There is this helper function where we can say .rio.bounds, which will extract the bounding box of each tile, and we can create a geodata frame out of this. And next we can just visualize this. So you can see now these are the bounding boxes of different tiles that we have read. And then this is the boundary of Sri Lanka. And we can see it fully covers the region of our interest. So when we mosaic this together, we'll have the full coverage. And finally, we just clip out the raster so that any pixels outside will be set to no data and we'll have nice mosaic for our required region. Merging has to be done spatially. That means the tiles do not have overlap. They have 1 pixel overlap, but that's it. So we want to join them spatially. And for doing spatial merging, we have a function called merge arrays provided by rioxarray. So it just needs a list of data sets. So we said, take these data sets that we've read, merge them, and we'll get a merged raster. And once the merging operation finishes, you'll get a single data array, which is the merged version of all the arrays. You can see each tile was about 3,600 rows and columns, and the merged one has 18,000 rows and columns. So this is a pretty large array that we have merged using a rioxarray. Now that our tiles are merged, let's go ahead and clip it out. We can use the rioxarray's clip function to clip it with geometry. So here we use the rioaccessor and the clip function to say, take the merged data array and clip it out with the geometry of Sri Lanka. So once we run this, it's going to set all the pixels that fall outside the geometry to be no data, and they won't be saved with the actual pixel value, but they'll be encoded as a no data value. And since we are using SRTM, the source data itself has a no data value set to negative 32768 number. This is fine. This allows us to save the data as 16-bit integers. We don't want, if you save it as NaN, it's going to be saved as a floating point number. So SRTM uses this encoding scheme where it says we have elevation data. So the negative 32768 will represent any fill value. So that's fine. If we are using this, we should also encode this in the metadata that this is the no data value. Do not consider it as a valid pixel value. And you can see we have this in our metadata already set as the fill value. So we should be all set, and we can just save out the results as a GeoTIFF file. Here we save the results to a file named clip.tiff. We are using the cloud optimized GeoTIFF format. This is a backwards compatible format, but it's a modern format which makes your dataset much more accessible. If you put it on cloud, it can be streamed instead of downloaded. So I always save out all my files, not as a regular TIFF, but a cloud optimized GeoTIFF. This increases the file size just by a little bit, but it makes your file much more usable by many software, including XArray and QGIS. You can also specify some additional compression option. Here we are using the deflate compression, which is a lossless compression, and a predictor, which also helps reduce the data size. Here we have the output folder and our clipped file is saved. Let's just download it and see it in QGIS. Here we have the downloaded TIFF file, and you can see we have this single TIFF file which is merged. We also have the pixels outside the geometry set to no data, and results look nice. We can also visualize this nicely. By default, it's a grayscale visualization, but we can change it to use color palette. And maybe we'll use this one and change the min-max value to be a little better. So there we go. We started with a bunch of separate SRTM tiles and a global file of admin boundaries. We selected Sri Lanka's geometry. We took all the tiles, read them using rioxarray, merged them, clipped them, and then saved it as a GeoTIFF file. Hope you enjoyed the tutorial. Do try out the Colab notebook where you can run this for yourself. You can also change certain parameters and see how it affects your outcome. If you have any feedback or you run into any issues, we have a comment section here. Feel free to add a comment. I'll be happy to address and respond to that. Thank you.